Okay. Now, why is it called hexa and decimal? Any reason why is it called hexadecimal? It might be taught, right, in DLD. What do you mean by hexa?
Because from 0 to 9 it is decimal numbers, and from A to F there are 6 alphabets.
Correct. So this logic is because you have 10 numbers and 6 alphabets. So for 6 alphabets they have taken hexa, and then remaining is the decimal part. Okay. So all the combinations from 0 to 9 and A to F are counted as hexadecimal numbers. Okay. So one simple question. You all have done the simple table, okay, of binary from 0000 to 1111. Correct? 0000 to 1111. So after 1111, which is 15 in decimal, what comes next in hexadecimal? F के बाद में क्या आता है? Any idea?
1F, 2F, etc.
Okay, so I'll just show. You have hexadecimal, okay, which goes from 0 to 9 and A to F. Okay, so from 0 to 9 and A to F, I have 0, 1, just a second. Okay, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I come to A, right? I cannot write 10. Then I have B, C, D, E, and F. So this makes my range. But it does not stop here, right? I cannot stop at F. The numbers which are there, they are infinite. So after that, what number will come? You need to know these tables, okay? Because it will be required for our all the calculations and conversions which are required.
Ma'am, is it 1A?
Okay, so what logic I'll tell you is, I have stopped at which number over here? I've stopped at which
9.
decimal number over here? 9. Decimal में 9 के बाद क्या आता है?
10.
10, right? So after F, I get the number 10. Okay, this you can also use your conversions जो आप लोगों ने already conversion किया है, okay, in the DLD. You can know that after F, it will continue the sequence of 10, 11, 12. Okay, then it will come to 13, 14, 15 up to 19. Okay, so 19 के बाद में now you stop. Okay, 19 के बाद में you cannot write 20 because it has to have an A after it. So after 19, I'll get the number as 1A. Then I'll get 1B. It will go up to 1F. Okay. After 1F, where did we stop here at decimal? 19. So after 1F, your number will be 20. And 20 se 29, then you will continue from 2A to 2F. Okay. So this is the way between every decimal numbers, you have to introduce the series of your alphabetical numbers. Okay. Why am I saying all this? Because in your microprocessors, okay, all you need is the knowledge of hexadecimal numbers. Sometimes for small calculations, I don't want you all to open the calculator. Okay, I had already passed a message to CRs that keep your scientific calculator handy. Okay, so now let us start with this chapter. You all had studied about what is ALU, that I gave you in short. Next is what are the types of buses you have, right? So we had learned about 3 types of buses. Okay, can anyone name them?
Ma'am, data bus, control bus, and address bus.
Very good. Okay, so we have data bus, we have address bus, and we have control bus. Okay. Now, what are the uses of these buses? Okay, these are only 3 buses which will run the entire microprocessor. Okay, the data which comes. I'll give you a simple example. Okay, everyone right now sends a WhatsApp message, sends text messages. You can send the email ID. You can send the emails, right? So for all these, also only these 3 logic are required. Okay, the logic of these 3 buses is very important. Okay, very first thing, address bus which is there. Okay, it acts as the address of email ID. Okay, that's your email ID. The phone number which you have is taken as an address. Next, if you want to send a postal address, if you are sending a courier, you require an postal address, right? So all this data which is there will be taken care by the address bus. Anywhere. Will you be able to send your data anywhere? Is it possible? No, right? If I don't enter a phone number on my WhatsApp chat, will I be able to send any message? No. If I don't write a physical address on my envelope, will the letter reach anywhere? No, right? So without the address, your data will be lost, and it first thing, it won't be able to go on. Data, whatever you write down in the message is your data. Whatever you send in the envelope is the data. Whatever you write in your email is treated as data. Okay. So data bus, even if data bus has some data, okay, but you do not have an address, that data cannot be stored anywhere else. Correct? So this is the basic of address bus and data bus. The third bus which is there is the control bus. Okay. Now control bus has various writing the data, okay, whether you want to send an email or you want to receive an email. Okay. For example, if I block someone on WhatsApp, okay, will that person be able to send me the message? No. That means I have kept the incoming or the reading of messages as off. So I'm not reading right now, but my control bus, which is there, in that writing mode is allowed. So I can write a message and I can send it to anyone. Okay, but unless and until I don't keep my reading messages on, I cannot receive any messages. Okay, so whether you want to read the message, that means whether you want to read the data, whether you want to write the data. Okay, all that depends upon your control bus. So overall, basic you all understood. What are the 3 buses and how are they used? Can I get some feedbacks?
Yes, ma'am.
Yes, ma'am.
Okay, so the 3 buses which are there are very important for us: address bus, control bus, and data bus. Okay, so since we have understood all this in the previous lecture, we'll now start with the actual architecture of the microprocessor which we are going to study. It was mentioned by Rupali ma'am that the microprocessor which we are going to study is 8086. Okay, we had seen what are the previous versions, we know what are the later versions, we had seen the number of address lines and data lines in 8086. So can anyone tell me what is the size of address bus in 8086?
20 lines. Ma'am, 20.
20 lines. Okay, so now simple, if I have 20 lines, okay, in my microprocessor, okay, what is the total memory of 8086? We need to find that. Okay, so there is a direct relation between number of address lines, okay, and the memory. So that relation is memory is equals to 2 raised to n, where n is nothing but the number of address lines. So this will give me 2 raised to 20. Okay, so quickly, can anyone calculate what is 2 raised to 20?
1048,576.
Okay, so it is 1048,576. Now, whenever we are dealing with microprocessors and the memory, okay, this memory which is there, it will always be, okay, you are taking a mobile phone, you are taking a computer, you are taking a memory card. What do you look at? The space, the memory, right? So what is the unit of memory?
Ma'am, GB.
Okay, you all go in GBs. Right now it is TBs and GBs. So now this particular number which is there, can anyone let me know in bytes? This
Ma'am,
is
1 MB.
okay. So this is simple bytes. So when I convert this, I'll get it as 1 MB. Okay, so you should remember this, that 8086 has total of 20 address lines. Okay, total memory is related to the number of address lines. So 2 raised to 20 will give me 1048576 bytes, which is nothing but 1 megabyte. Okay, so the internal memory of 8086 is just 1 MB. Okay. Next, when I have to see this memory, okay, so a mobile phone, अगर उसका memory है, does it store only images? Does it store only video? Does it store only music? No. What does it store? It stores everything. Okay, and everything has their specified folders. Correct? Your images are not mixed with music. Your music is not mixed with videos. Correct? So it is your mobile phone is smart enough to segregate by looking at what type of data you are writing. Correct? So depending on that, not depending on that, the knowledge of that you have directly the mobile phone. Okay, we'll see in basic how is it used and how 8086 is there, and from 8086 how we develop to your other processors. Okay, so looking at this slide, it tells the architecture of 8086. Okay, so architecture of 8086 basically tells you what are the registers inside. Okay, now there is a difference. You can't call it as resistors. Okay, resistor is the hardware device that you connect, which is denoted by R. Okay, these are called as registers, which you have learned in DLD, the shift registers and all. Okay, so this is what is there in your 8086. Okay, this part, not this part. So we have different registers which will store different type of data in them. Okay, so looking at this diagram, you can see that it is divided into two parts. Okay, the first part is called as BIU, okay, which is called as bus interface unit. Okay, in this bus interface unit, if you can identify what is this? This symbol, has anyone seen it?
Ma'am, it's a summation, right?
Summation.
Okay, that's that's a symbol. Okay, this is a symbol which is there. I'm talking about an entire shape.
Oh, ma'am, it is some kind of gate.
Okay, any other answer? Or else I'll ask a question in a better form, a simpler form. Okay, so everyone told me that this particular sign is of summation. Okay, what is summation? Addition. Okay, and what is addition? It is an operator. And what does it do? Arithmetic or logical additions, right? Is it okay if I add 98 and 23? Will I get the answer?
Yes.
Okay, and if I write 1C plus E4, will I get the answer?
Yes.
Okay, this is your normal decimal, and this is by visualization only you will come to know that it's an hexadecimal. Okay, so all the additions which are there, okay, this is that particular unit which will do the arithmetic and logical operations. So this part is your ALU. Okay, so you should always remember this sign which is there. Okay, this shape which is given over here is a shape of ALU. Anywhere if you will see, the ALU will be denoted in this particular shape. Okay, so if you see ALU in your computer, if you don't have a CPU, will your computer work?
No.
No. Why? Because startup में ही CPU के मतलब for your computer startup में ही आपको CPU लगता है. Your power comes in from that particular thing only. Whatever you store will be a part of CPU. Now CPU has lots of things inside it. Will not go inside in that detail, but similar things are there in 8086. Okay. So very first thing is it had an ALU. Okay. Next. You can see some of the buses which are there. Okay, so you can see this as a B bus, you can see this as C bus. Okay, as of now, just look at the blue side, that is the bus interface unit. Okay, so you see ALU which is there, it is connected to everything. Okay, it is connected to this section which is there in your BIU, it is connected to this section of BIU. It is having bi-directional, it is going also and it is receiving also. From this particular thing, it is also getting connected. So you should see what are the arrows. Okay, you should know the arrows. So if it starts from this and it also has this end, that means it is bi-directional. Okay, what do you mean by bi-directional? You can send and you can receive. Okay, the transmission of data can be done to and fro this particular ALU. Okay. Now ALU may, if I want to do addition, I need to give a data, right? So 98 and 23 or 1C and E4, it should be sent to ALU, right? So that's why it will receive a data, okay, from here or from here, anywhere it can receive the data. And after the calculation, whatever is the answer, that answer I'll have to send it again. You have your calculator, you are doing the addition 98 plus 23, but it is not displaying the answer. Why? Because it's a unidirectional bus. So what's the use? There is no use, right? So everything is bidirectional. This particular thing, it is going only in one direction. Okay, so only a data from this particular section are given to ALU, and data from ALU is passed to all these devices. So at a time, I can either give the data, at a time, I can either take the data. Now again, this has both the ends as arrows. So again, it is bidirectional. Okay. Just give me a minute. Okay, so these are some sections. Okay, next part, the second half of this architecture is called as EU. Okay, which is called as the execution unit. Okay, so here in the execution unit, whatever the executions take place, the major execution, okay, that will be taken care by the EU. Okay, which is the bottom part. So now in the next slides, we'll see everything what is there in detail. Fine. So the two sections which are there separated. So EU and BIU, they both will function separately. Okay, they are not interconnected. They will both function separately. So what does a BIU do? Okay, that's bus interface unit. It will fetch the instruction. Now, what do you mean by fetching of instruction? Okay. When we write down the programs in 8086, okay, it is not in English. It has its own language. Okay, like in your previous semesters, you have learned C programming, C++, and Java. Okay, so can I write a simple English in Java? I'll tell that I want to add 12 plus 2. Can I write that in Java? No, it has its specific format. Right? It has a flow, it has specific predefined commands which are to be written, and only those can be executed. If you write something wrong, it will give an error. Similarly, over here, there are a set of instructions which are already given. Okay, so I'll tell you an example. I want to have one register. Suppose I'll name that register as X. Okay. In your C and Java, X variable, okay, you call it as variable. In the variable, I'm storing 20. In another variable Y, I'm storing 30. Okay, and I want the answer in Z. Okay, whatever is the answer, I want it in variable Z. So in Java, you can write down the code. In C programming, you can write down the code. Okay, what is my instruction? What do I have to do? I have to do add x and y. So simple, it is x plus y, and your answer is to be given in z. Okay, so this add instruction which is there, okay, this add instruction which is there, it will be given in DIU. It will check what instruction it is. Is it add or is it subtraction? Okay, I can as well subtract. Okay, if I have two variables, I can either do x plus y, I can do x minus y, I can do x multiplied by y, I can do x divided by y. All the instructions I can do, right? But you are specifying as of now that I want to just add this. So this add is called as a instruction. Okay, so this add which is there, it means it is fetching. Now this add also which is written over here is not in English. Okay, it will have some hexadecimal notation. Okay, it will have some hexadecimal number which is given, which is fixed. Every time I write it down as add, I'll have a number 3e hex which will be fetched. Okay, so there is a complete directory. Okay, starting from 00 till ff. Okay, or it may go beyond that also. Right now, all the instructions which we have are from 00 to ff, or it may have a 4-digit data. Okay, so all this have predefined. If I'm writing add, it will have its own number. If I write down subtract, it will have its own number. If I write down division, it will have its one number. Anything, it can be anything. Okay, we don't have to remember this particular numbers. These numbers which are there, okay, these numbers are converted from the internal memory, okay, which are already stored, and your BIU will fetch it. Okay, your BIU will fetch that particular number. So whenever I'm writing add x and y, okay, this is visible to human eye. Okay, we can see this on our screen, but inside the microprocessor, it will write down 3a, 20 and 30. Okay, so 3a is just an example. I'm saying that addition ka number ho sakta hai 3a. So it will be 3a hex, 20 hex and 30 hex. X ka value we had defined as 20, y ka value we had defined as 30. Correct? So the code will not be add x comma y for microprocessor. The code for microprocessor will be 3a, 20 and 30. Okay, for one particular instruction. Am I clear? Understood this?
Miss, can you please repeat again?
Okay, so simple. Microprocessor which is there, it is designed to do arithmetical and logical operations. Okay, so I'm taking a simple example of addition. Okay, I have two variables x and y. Okay, two variables as x and y. I'm talking this in terms of your Java and C programming. Okay, in your 8086, instead of x and y, we'll be having registers. Okay, 8086 does not have variables, they have registers to store the data. Clear? Now, for addition or subtraction or division or multiplication, okay, anything that I do, even assigning the number to variable x, assigning the number to variable y, okay, I have a opcode. Okay, I have a specific number. Okay, so this number is already defined or it's already stored in your microprocessor. Okay, you are writing this code that I want to add x and y. So I wrote add x comma y. This is the way we will write down the instructions. This you have understood. For your ease, microprocessor will convert this add into its instruction number. Add ka equivalent instruction number is given as 3a. Okay, then x है, तो x का value क्या है? X का value I know it is 20. Okay, X value is 20. So I'll get the number as 20. Next number is Y. So Y ka number, what have we assigned to Y? We have assigned 30 to Y. Okay, so instead of us looking at add X comma Y, I will be seeing the code as 3A, 20, 30. This will be the way we can see the code in microprocessor. Clear now?
मिस हेक्स नहीं लिखते मतलब कोड में.
In the numbers, when we define, I have written hex, right? Okay, whenever I want to assign a number, I will write it down as hex. Now suppose मैंने लिखा x is equals to 20 hex and y is equals to 20. Okay, it will not take y as hex. It will convert the decimal number 20 into hex. So decimal 20 is nothing but, can anyone tell me? If I have decimal 20, what is its equivalent in hexadecimal?
Miss 15.
Everyone has a calculator? You all know how to use calculator for the conversion of number systems? You all don't know it? You'll require it. So what I'll suggest is everyone has a calculator right now. So I'll just show you how to do it. So everyone please take out your calculators. In the calculator, when you go to mode, okay, click on mode and you can see that I think so it is 4 where the base is written. So click on that 4 after clicking on mode. Done? Yes?
Yes, ma'am.
So can, now on the side after any of the number which is visible, can you see either D, H, B or O? What is visible right now? D?
Yes, ma'am. D.
D, right? Everyone is having D as the number, the alphabet after the number. So this means it is a decimal number
Sorry,
system.
ma'am, can you repeat the last part?
Okay, you have to press mode.
Yes, ma'am, I did that.
Okay, after mode, you have to look on the screen where you have base. I think so it is 4, number 4 in the
Okay.
new calculators, right? So press 4.
Yes, ma'am, got it.
Okay, so now you will see 0 and there will be a small alphabet written as D. Correct?
Yes, ma'am.
Okay, so this is your decimal number system. Okay, so now just type in 20 and press equal to. Okay, so right now you can see 20 and D. So that means it is decimal 20. Now
No,
on your
ma'am, it's showing 2020. Whenever I press
just on the top part it will show 20, on the answer part it will show 20, and in the answer side it will show a D also. Correct?
Yes, ma'am.
Okay, so this is your decimal 20. Now on your keypad, okay, anywhere on your calculator, just check, it will be written as decimal, hex, binary, octal.
Yes, ma'am.
Okay, so just press the button where it is written hex. Done. What is the answer now it is showing? On the top part of the screen, it will be 20. On the lower part of the screen, it will be
40.
14. Okay, and 14 ke baad mein which alphabet is there?
Fine.
H, right? Correct. It is not D, it is H. So
Yes, ma'am.
20 decimal is equal to 14 hexadecimal. Correct? The same way, if now after 14, if you just press binary, it will convert your 14 into 14 hexadecimal or 20 decimal into binary. So what is it coming in binary?
Miss, just one doubt we had. We are using a diploma calculator, which is FX82MS. And
Any of the calculator you use, you will have the base mode.
no, miss, so here when we press mode, we just have three options, which is comp, SD, and register.
No, you keep on pressing the mode multiple times. You'll be able to see it. I have more older calculator. So you have to just click on mode. It will give you some option. Press it once again. You will see next set of options. If you can't see base there also, you can press it one more time. It will give you new set of modes.
Yes, miss,
So-
but so it's still not there. So one is comp, SD, register, REG. Then one is DEG, RAD, and GRA. And when I press it again, it's FIX, SCI, and NORN.
Okay, can you do one thing? You can start your camera and show me the calculator screen.
Give me 1 second. Miss, can you see the calculator? Oh, wait.
No, your background is there, virtual
I
background.
just remove that. Miss, so can you see it now?
Yeah, just a sec. It is too close by. Just take your phone a bit away. Yeah, press this mode, which is next to the, yeah. Click it. Next. 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 Press 2. Okay. Press the arrow button.
Right or left, miss?
Anything.
No, miss.
Okay. Click on the mode again. Acha, you are in which mode right now?
Miss,
I
right
can't
now I'm
see.
on normal mode, if you can see.
What is on the top? Yeah, that. What is that? M.
M.
Okay, that's a
It's an
memory.
M.
Fine.
Yeah.
And this one is written as what?
R, miss.
Okay, do one thing. Press Shift, Mode,
Mode.
and 3.
3.
Okay, equal to 2 times.
Mhm.
Okay. Now go to mode again.
Oh, just one. Mode. Hello, ma'am.
Yeah. Next. Is it coming the same thing?
Yes, miss, the same thing's coming.
Okay. Then you need to look at your the user manual where it is shown as
But miss, this is the FX82MS. Is it supposed to have base function?
okay. Just show me the whole thing. The keypad mode. Don't turn it.
Okay, miss.
Okay, this is way older than 91. Okay, because see, on the raised to sign log and natural log, you will be having the decimal, hex, binary, and octal, and x inverse. Okay, that x inverse पे कुछ लिखा है? No.
Miss, X, nahi.
Okay, so this calculator does not have that function.
Okay, miss. No, actually in diploma, this is the one we needed to get, which is 82 ms. I think we need to get some 91.
991.
Yeah. Okay, miss. I'll get that tomorrow.
Okay, not an issue. You can use it, use the one which is there in your mobile or your computer as well. Even
Okay, miss.
that is there.
I'll do that, miss.
Okay. Anyone else has having a doubt in how to see it? Everyone could do the conversion.
Miss, actually, all the DSY students might have this problem because we're going to use the same calculator.
Okay, so what we'll do is I'll show the. Okay, can you all see the calculator? Computer calculator?
Yes, miss.
Yes, ma'am.
Okay, so just click on these 3 lines and you can go to the programmable calculator. Okay, so here when you just click on the mode, it will give you all the options. So when you come to binary, it will allow you to enter the numbers only 0 and 1. When you come to octal, it will come only from 0 to 7. When you go to decimal, it will be only the number pad. And when you come to hexadecimal, it will give you an alphabet numbers as well. Okay, alphabet as an input. So I wanted to convert 20. I'll just write down 20 and it will show me what is there in hexadecimal, what is there in octal, and what is there in binary. Okay, but since you all may have the exams offline, that's why I told you how to use it in your calculator. So for exam point of view, please try to get this calculator, which will be helpful. Okay.
Miss,
Fine.
could you just repeat the specification again?
Minimum is FX991 MS. Anything above that will be fine.
991 MS. But
Yes.
this will be even applicable, I mean, usable for the exam.
Anything. This for engineering purpose and minimum usage, this is fine because what the other calculators have. Okay. So that calculators have more things to plot the charts and all, but all that you don't require in your exams, right? Or any of the subjects. You have to do it manually. So it's better to take the simpler one, which is FX991 MS, which suffices all your requirements.
Okay, miss. Thank you so much.
Okay. Yeah. So let us continue where we stopped. We had done the conversion. Okay. So this is how you have to do the all the conversions are given. Okay, so when you mention hexadecimal, it will take it as 20 hex. But if you just write down 20, it will automatically convert it into 14 hex. Okay, so whenever you are giving the value to any of the variable, it has to end with a hex. Okay, if it is not given with a hex, that means it will convert it automatically. So this is what it is. It will fetch the instruction. Okay, whatever are the instructions, that means this. Okay, it will be fetched. So it will come to know that, okay, now I have received 3A. That means I have to return the answer as the addition of 2 numbers. Okay. Next, the next thing which your BIU does is reads data from memory and IO ports. Okay. Now, what do you mean by reading the data from memory? Simple. You all have your mobile phone. Your mobile phone has your SD card. SD card is called as the memory. You also have the internal memory. Okay. If you want to take some data, okay, you have to obviously go from the to the memory card or the internal memory storage. So whatever the data is there, it can be read, okay, from the memory. That means you can open your images, you can open your videos, you can open your documents, you can open your music, anything. So that means you are reading the data from the memory. Next thing, what it does is writes the data to memory. Okay, writes the data to memory means what? When you are pasting any of the image from one location to another location, that means it is writing a data. When you click a picture, that means it is writing a data. When you open a Word document or your Excel document in your phone, and if you write it and if you save it, that means it is writing it into the memory. When you access it, it is reading. When you save it, it is writing. Okay, that part is for the memory. The next part you can see is the IO ports. Okay, you can see this IO ports. Now, what is IO ports? It stands for input output ports. Okay, so a simple example of input output ports is for your mobile phone. It is your microphone, your speaker, your OTG, and for your computer, it is for a computer, it is USB devices, your mouse, anything which is input output. Okay. So for all those ports also, there has to be a data. Okay. So first thing, when I do a right click on my mouse, okay, computer mouse, when I do a right click, okay, then what happens? It's a command which is given to your microcontroller that it is right clicked. So it will show me only right click. When I do right click, will it show me the left click commands? No. Okay. When I say what it has to do, it will exactly do the same thing. So IO ports may be, there can be data which is given. Okay. If I'm connecting an OTG to the mobile phone, if I'm copying the data to OTG, that means I'm writing the data to OTG. When I'm copying something from OTG and pasting into the phone memory or my SD card, that means it is reading the data. Okay. So what the microcontroller, in the view of microcontroller, that means reads and writes. Don't get confused what is reading and what is writing. Okay. Clear this much? What is a BIU? No answers? That means you have not understood?
No, ma'am, understood.
Ma'am, understood.
Great. Okay, so simplest first part is your BIU for 8086. Okay. Next part. Okay, there is someone in the chat who is asking me to repeat. Okay. So simple thing, BIU. Okay, you want me to repeat BIU, right? Or read write? BIU. Okay. So we'll take this summary before ending the lecture. Okay, so at that time I'll tell again. It is very simple. BIU is fetching the instruction that you understood. Whatever you tell them to do in the human language, it will convert it into its own language. That is fetching of the instruction. Okay. Next, reading the data from the memory or IO ports. That means whenever you are accessing some data from any of the other memory, that means you are reading it. Okay. Writing the data means whenever you are opening an application, when you are modifying any of the application, that is called as writing the data. Okay. So this is a simple summary of BI. The next unit, the lower unit which was there, is called as the execution unit. Okay. The execution unit will execute all the instructions that are being fetched by BIU. So execution unit has only one thing to do. Whatever BIU has fetched, I have to execute it. Correct? So this will keep on getting simpler as we progress. So what is the role of BIU? You have to write down 3 points. What is the role of EU, that is execution unit? You have to write down whatever it is fetched already by BIU, it will execute it. Okay, so simple point. So now let's go into a bit of detail. What were the different parts in your BIU and EU and start understanding them. Okay. So very first thing is the general registers over here. Okay. Just a sec. There is some problem with my computer today. Okay. So first we'll see what are the registers. Okay. If you see this diagram, okay, this particular thing which is there, it is explained. Okay. This diagram is just tilted. Okay. It is tilted in this direction. Okay. So this EU and BU will be now this way vertically. So it is just tilted. So that's how we can see the registers over here. Okay. So these registers which are there, you can see there is something, some alphabets written, AH, AL, AX, BH, BL, BX, CH, and DH, DL. Okay. So what are these are? They are the registers which are available with your 8086. Okay. So while Rupali ma'am had told you about 8086, we know that address lines are 20. Okay. Ma'am had also told you what are the data lines, right? So anyone can tell what is the data lines?
Ma'am, 16.
Correct. So address lines 20, okay, and data bus is of 16 bits. Okay. Make sure you are writing the units for everything, 20 bits and 16 bits. So now if I say address bus and the relation between address bus and data bus, right? 16 bits means I can store the maximum data of 16 bits in any of the registers or any of the memory of 8086. Okay. So if I tell the registers, all these registers which are there, they are of size 16 bits. Okay. But I'll also say that I have only 4 registers which are of 16 bits. Okay, so you can see AX, BX, CX, and DX. Okay, these registers are of 16 bits. Okay, now whenever we do the programming in 8086, okay, it is always good to have a smaller code, or is it good to have a larger code which takes more memory?
Smaller code.
Smaller code, right? So now if I have a data which is only 8 bits, will I use or will I waste the entire 16-bit register?
No, ma'am.
No. So here in 8086, there is a provision given that AX register which is there, it is split into 2 registers which are AH and AL. Similarly, B, C and D are also divided into BH, BL, CH, CL, DH, DL. What is the significance? The names which are given to all these registers are also logical. Okay, so we'll follow all this to do our programming. First, AH, okay, register A is used as an accumulator. Okay, what do you mean by accumulator, or what do you mean by accumulating?
Collecting.
Collecting. Okay, so whatever operations that we do, the results of that, okay, the collection of that, okay, is taken in accumulator. So I can say accumulator is the most important register in 8086. Okay, all the operations that we do, the answers will be stored in accumulator. Okay, next, the other register is called as BX. Okay, so BX stands for base register. We'll see this in detail. Again, they are divided into BH and BL. CX is used as counter register. Okay, counter means whenever you want to count something, we'll be using counter register. Next is D, which is used as data register. Okay, now there is no hard and fast rule for using B, C, and D. Okay, but accumulator is the most important. One data has to be compulsorily stored in the accumulator. So if you remember in the previous slide, I had written X is equals to 20 and Y is equals to 30. Okay, these are the hexadecimal numbers which I have stored. So what I'll do is, now, first of all, before storing, tell me the bits of this number. How many bits are these numbers? Come on, this is so simple.
16-bit.
Can you prove it? It is 16-bit.
Ma'am, it is a decimal number, not so.
It is a hexadecimal number, but for every hexadecimal number, you should have bits, right? We are talking here. Okay, if you see this part, I'm writing it as a data is 16 bits. This is hexadecimal. So everything for the memory, it has to be in bits, right? So this particular 20 hex and 30 hex, there are how many bits of numbers?
8 bits.
8 bit. Okay, you can do this calculation in your mobile, sorry, not mobile, the calculator which I told. Okay, the simple thing is every number, every binary number that you have seen in the conversion, it starts with what value? Your binary number starts with
0,
0, 0.
0 0 0 0, then it goes to 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0, right? And it will end at 1 1 1 1. So for basic 15, 0 to 15, you have 4 bit of data, right? After 1 1 1 1, you cannot have a 4 bit data. It will go to a 5 bit data. So this hexadecimal number, you all remember the conversion from binary to hex and hex to binary? What do? You make a group of 4, isn't it?
Yes, ma'am.
Correct? So now this is a hexadecimal number. I want to convert 0 into binary. What do? You make it a group of, you take it in a group of 4. So it will be 0 0 0 0. So it becomes 4 bits. Next is 2. 2 is over here. Again, it will be taking it as 4 bit. 0 0 1 0. So 4 plus 4, this number is 8 bit. Okay, so in hexadecimal, if 2 digits are written, that means it is a 8 bit number. Okay, if there are 4 digits mentioned, then it will become 16 bit number. Correct?
Yes, ma'am.
Yes, ma'am.
Okay, so now we have seen that this number is a 8 bit number. Now to store this 8 bit number, I will not waste entire accumulator, okay, AX. So how do we write it down in 8086 is, it will be AH, or I'll take AL, any of the register, okay, and I'll move what number? 20 hex into it. You can move 20, you can move 30, any number. Any one number has to be in accumulator. Addition and multiplication, it does not make a difference which number you take first, which number you take second. But for subtraction and division, it will make a difference. That we'll see while programming. Okay. So this is AH and AL. If I want that data into AX, what will I have to do? I'll have to convert it into a 16-bit number. So that will be 0020. Okay, so when I do this, it is wasting the memory. Okay, it is wasting the memory which was there. Okay, so instead of wasting the memory, what I'll do, I'll just use AH or AL. Okay, for a 8-bit number. Next, the equation, instruction. We are not yet at the instruction, but simple. Storing means you are moving it. So I'll just write down move AH, 20 hex. Okay. This is the way your first instruction goes. Okay. So in your first instruction, this format or the syntax is, this will be your instruction, whatever the instruction you want to do. Okay. Moving, adding, subtracting, multiplying, division, anything. This is the source, and this is the destination, and this is the source. So the direction of movement is from outside to inside. Okay, the data which is written at the last is the source, which will be moved to the number or the value which is mentioned over here. Okay, so 20 hex is moved to accumulator higher byte. Okay, AH में. AL is the lower 8 bytes, lower 8 bits of the accumulator. Clear? So,
Ma'am,
yeah.
if I want to store the 20 H in AL, that is also fine, right? There's no
Yes.
compulsion.
There is no
to-
compulsion at all. Okay, in the
Okay.
programming. Okay, this is your entire 8-bit of register. Okay, if this is your 8-bit of register, the 4 bits starting from, sorry, starting from 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so 7 bits, 0 to 7 makes it 8-bit. Okay, so from that 0 to 3. Okay, 0 to 3 is defined as AL because it is the lower part of the register. 4 to 7 is your AH, okay, which is the higher byte of accumulator. AH plus AL together makes the register AX. Am I clear? This is applicable to all the registers, all 4 registers which are there. Okay, so same will be BH and BL will make as BX, CH and CL will make it as CX, DH and DL will together make it as DX.
Miss, what is BX, CX, and DX? Can you
Okay, they
please
are
tell?
the name of the registers. Okay, AX is accumulator register, BX is base register, CX is counter register, DX is data register. We'll study all this in detail. Okay, there are the names which are given to them also have some reason. Okay, clear till this point?
And Miss, each register will be of 16 bits, no?
AH will be 8 bits, AL will be 8 bits. Okay, as mentioned over here. Okay. Okay, AH and AL. This is, I have shown this as 0 to 7. The total AH will be 0 to 15 bits. Okay.
Ma'am, can you clear that AX is equal to 0020 hexa?
Just a minute. I'll clear which.
AH comma AL is equals to 20H. Below that, ma'am. AX is equals to 0020H.
This one.
No, ma'am.
Okay, this one.
Uh-huh.
Yeah. What about that?
Yes, ma'am. That 0020H. Like.
Okay. So let me clear the confusion. Just give me a minute. Okay, we'll do one thing. We'll take a break. Okay, we'll take 5-7 minutes of break and then we'll come back. Okay. So it is 10 at 10:45. Okay, 10 minutes break. If anyone has any doubts, can ask me. I'll be here only.
Recording stopped.
Yes, Ananya?
Ma'am, you said that AL is 0 to 3, right? But shouldn't it be 0 to 7 because...
Yes, it will be 0 to 7.
Okay.
I just made a box to show the half-half.
Recording in progress.
Right now, when we study all the registers in detail, I'll show it in proper manner. 0 to 7 is the half and then 8 to 15 is the second half.
It's the second half. And okay. Okay, ma'am.
Ma'am, actually I got it. आपने वो condense कर दिया ना bits को 0
Yes,
0
yes. I just showed it in half.
Okay, I must have missed that point. Okay, ma'am.
No worries, no worries. We'll see it correct right now again.
Okay.
Anyone else has any doubts? Make sure everyone returns at 10:45, please.
Recording stopped.
Okay, everyone back?
Yes, ma'am.
Yes, ma'am.
Okay, the ones who are back can please raise their hands.
Recording in progress.
Quickly, 130 participants and only 45 hands. What about others? जिनका hands raised है उनको second hour. If you don't raise hand, no attendance for second hour. Just attending the Zoom meeting, keeping your phone aside, keeping your laptop on and roaming here and there is not going to give you the attendance. Okay, so this is it, 78 participants. I'm clicking a pic of this 78 hand raises and the attendance will go only to them. Okay, done for 79 students. No more hand raises, please. Okay, so let us continue. We were over here at the registers. We talked that all the registers have a specific name, register A, B, C, and D. Okay. Programming wise, for if you want 16-bit, we will call them AX, BX, CX, and DX. If you want them as 8-bit, it will be AL, BL, CL, DL, or higher side, it will be AH, BH, CH, DH. Okay. So we were talking about the breaking of okay, how the registers are designed. Okay, so I will have this register. I'll have AH as the higher side and I'll have AL as the lower side. This lower side will start from 0. This will be 7. Okay, this will be 8th bit and it will end at 15 bit. So 0 to 15 will give me total of 16 bits. Okay, so the addition or the combination of these 8 bits and this 8 bit will be 16 bit, which will be called as register AX. Okay, this is same as or it is all similar to BX also, CX also, and DX. Okay, all the registers will have division of 2 registers, which consist of the lower part and the higher part. Now, what is the lower part and what is the higher part is, if it goes from 0th bit to the 7th bit, it is called as AL or the lower bit of accumulator. AH, which goes from 8th bit to 15th bit. Okay, so in the example, I can write down move AL, comma 20 hex. Okay, so 20 hex will be stored over here in this place. Okay, if I write the instruction move AH, comma 35 hex, then this 8th bit to 15th bit will be loaded by 35 hex. Okay, if I write down move AX, so if I write down move AX, will I require 2 bits or will I have to upgrade it to 4 bits?
Upgrade to 4 bits.
4 bits.
Ma'am, 4 bits.
So considering the same example, okay, considering the same values, कि मुझे AL में 20 चाहिए और AH में 35 चाहिए. So together combine I'll do is the higher bit is which one? 35. 3520 hex will be the combination. It will also give the same part. 0 to 7 में it will put 20, and from 8 to 15 it will put 35. Okay, if I write down move AX comma 3520 hex. So this one instruction, and this will go to 2 instructions, but both are doing the same thing. Okay, both will do the same thing, but every time we may not require both the numbers loaded with the same way. Okay, so we will not use AX. If it is just 8-bit, we will use AH and AL. Okay, this implies to all 3 registers as well, BX, CX and DX. Okay, done. Understood about the 4 registers? Just the basic that they are 4, they can be divided into 2 halves of 8 bits, AH and AL, higher part and lower part. Okay. Next, when you go for the execution unit, the next is the data bus. Once you have set the address, the rest everything depends upon the data bus. Okay, once the address is set, rest all the transfer of things between the source and destination is the work of data bus. Okay, so we have this data bus. This temporary register, we'll see it in detail. Then you have ALU. Whatever is the ALU, we will it will take place over here, and the flag register. Okay, flags means when you do the additions, okay, there is a chance that there will be carry generated, right? If I am doing, okay, everyone can take out their calculators, go to the hex mode. Okay, everything that we'll do will be hexadecimal, right? Then type in the alphabet FF plus FF. What is the answer? FF plus FF, hex.
1 FE.
1 FE. Okay. So now my registers which are there, they are of how many bits? 8 bits. 8 bits means how many digits? 2 digits. How many are these going to? 1 FE is how many digits? 3 digits.
3 digits.
Right. So can I accommodate these 3 digits in a place of 2 digits? No. Right. So simple logic. You have answer as FE with a carry of 1. Can I say it that way?
Yes, ma'am.
Okay.
Ma'am,
So
could you please repeat the conversion of hexadecimal?
Okay. I want to do FF hex plus FF hex. The answer will be 1 FE. Okay. So F plus F will give me answer E. Okay. Whatever is the answer, but here it will be E. Here again it is taking as E. Just a minute, students.
Till that point, if you have any doubt, you can ask. Yes, student.
चल रहा हूँ. Yes, sorry students. So I want to do FF hex plus FF hex. Okay. So the answer of F plus F is 1E. Okay, if I do F plus F, your answer is 1E. So I can write down 1 over here and E over here, right? Again, F plus F is 1E and plus 1 is what? 1F. So I'll write down 1 over here and F over here. Okay, so this carry which is there, it is taken down. So this is your carry, I can say. So to indicate that your answer is not FE, जो हम लोग का answer 8 bit का दिखेगा, that answer will be just FE. But is it the correct answer? No, the correct answer is what? 1 FE. This one carry which is there, okay, it can be denoted at the flag register. It is one of the bits which will indicate that this particular answer is incomplete. There is a carry, and carry will always be maximum 1. Okay, maximum carry will always be 1. If you do any of the calculations in your calculator, okay, do the calculations, any calculations, your maximum carry for hexadecimal numbers will always be 1. It can never be 2. Okay, the maximum will be always 1. Now, the maximum 4-digit number for hexadecimal is how much? FFFF. Correct? Is everyone alive?
Yes.
Correct. Okay. So I have FFFF and as the maximum 16-bit number. Okay. Out of which I am taking only 8-bit. Okay. And this 8-bit is also which is there FF. Can I say this is the 4 bits and this is another 4 bits? Right?
Yes, ma'am.
So when you do the addition, I have seen one carry over here. I have seen one carry over here as well. Right? So we should not forget this carry also. So when you have something which is not a final carry, okay, there is a carry which is something different than the final carry. It is called as the auxiliary carry. Okay, this is denoted by AC, auxiliary carry, and this final carry which is there, it is defined by CY carry. Clear the notation? Clear.
Ma'am, can you repeat the notation once?
Okay, there are 2 types of carries. Okay, one is your final carry which we have seen, but there is also a supporting carry. Right? There is also a supporting carry.
Yes, ma'am.
The supporting carry is called as the auxiliary carry, which is AC. Okay?
Okay.
And the final carry of your answer is the carry which is denoted by CY. Okay?
CY, okay.
CY and AC. So this notations or this indication to the microprocessor is given by the flag register. Okay, it is always given by the flag register. You take any example. आप लोगों ने binary addition subtraction किया था in DLD. Similarly, calculator use करके ही if you do this 1 bit 1 hexadecimal digit का addition, you will see that the carry will never cross 1. It will never be 2. Okay. So this is what the flag register will do. Right now, I'm giving you an example of only 2 carries, which is auxiliary carry and the carry. Rest all we'll keep on seeing when we see in detail, also in programming, also in some examples. Okay. The next part is the.
मैं सिर्फ कोड में लिखते वक्त कैरी कैसे फिर आपने बोला था ना कि 3 बिट्स नहीं अलाउड है, सिर्फ 2 ही बिट्स अलाउड है ना?
हाँ, so that's what I told ना. Okay, I will just a sec. Can everyone see the whiteboard? A plain whiteboard?
Yes, ma'am.
So, I have to do the addition of suppose 63 hex and 4E hex. Okay. Now, doing the basic calculation, okay, child sort of calculation without using a calculator. I want to do E plus 3. ओके E plus 3. तो E के बाद में क्या आता है E F. राइट? E के बाद में F आता है, F के बाद में क्या आता है? 10, राइट? अरे आंसर दो बाबा.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So E to F is +1, F to 10 is +2, and 10 to 11 is +3.
Yes, ma'am.
Okay. So now I am taking only one digit over here. E and 3 are one digit. तो अगर मेरा आंसर 2 digit में जा रहा है, तो what do? You take the lower digit over here and the higher digit you give it over here. Right?
Yes, miss.
Simple maths में आप ऐसे ही करते हो.
Yes,
So this is first carry. So अभी ये जो carry है, okay, this is not your final carry. This is what? जो हम लोग ने units place में जो number है, उसके वजह से जो generate हुआ carry है, that is called as your auxiliary carry. Okay? Now next, what you will do? You will have 6 plus 4 plus 1, correct?
Yes, ma'am.
Yes, ma'am.
So 6 plus 4 is what? In hexadecimal, mind it, in hexadecimal.
Means
Don't tell me
A.
the answer in, yeah, correct. So 6 plus 4 is A. A plus 1 is what?
B.
B. So my answer here is B. Okay. Now addition of 2 digits, what is the resultant answer? It is also 2 digits, right? So suppose I had AH is equals to 63 hex. I had AL is equals to 4E hex. Okay. Now, जो answer store हुआ है, that always starts to accumulate from the lower side. Okay, bit 0 पहले load होता है, फिर bit 1, फिर bit 2, फिर bit 3. Okay, so it will be lower side. वो store होगा AL में. क्या store होगा AL में? B1. Okay, so by this answer which is there, this value 44E hex, that got replaced by B1. Okay, next, this is the example which I gave of 2 bits without the carry. Okay, now if I take, let me take the example of 4 bit which will generate a carry. This is the maximum number, right? 16 bit mein this is the last number. Okay, 4 digit F is the last number which we can take. So let's take the addition of the last number. Now, F plus F is what?
1E.
1E. So 1 is the carry. I write down E. Again, F plus F is E. E plus 1 is what?
1F.
1F. Okay, so I'll get 1 over here and F over here. Again, F plus F is what? 1E. 1E plus 1 is what? 1F. So I write down 1F. Last, F plus F is 1E. 1E plus 1 is 1F. Okay, ये समझाना तुम लोग को 1E plus 0, 1. So E के बाद क्या आता है? Plus 1 किया तो F. So I'm writing down F over here. And this will be 1. So answer is 1F. I hope you have understood this.
Yes, ma'am.
Okay.
Yes,
so 1
miss.
plus F plus F again is 1E. 1E plus F is, 1E plus 1 is 1F. So I'll write down F over here. And I'll write down 1 over here. So can I consider this as 0, 0 like your childhood? Then 1 plus 0 is 1. Okay. So this 4-digit number which was there is now converted into 5-digit number. Okay. Now, अपने पास में कितना space है? This will go into AL. This will go into AH. Okay, what did I tell you? The result of any operation will always be stored in accumulator. Correct?
Yes, miss.
Okay, so the lower byte है LSB, MSB आप लोगों को पता है. So I'm not going into detail of that. So the least significant bits which are there, they'll go into AL. The most significant. Do we have any space to put this one? No. We do not have any register where the carry can be stored. So for that, we have a flag register. Okay. Flag register is also of 16 bits. Out of the 16 bits, 1 bit is of carry and 1 bit is for auxiliary carry. Okay. So whenever any of the carry is generated apart from the main carry, okay, this I'll call it as main carry. Okay, this is your main carry. Apart from main carry, if any of the carry is generated, I will call it as auxiliary carry. Okay, and if you have a final carry, that will be treated as carry. Okay, just have a look at this slide.
मिस मतलब फ्लैग रजिस्टर में 1 बिट कैरी और ऑक्सिलरी
Yes,
कैरी
it will denote by 1 bit that your carry is generated out of this final answer. Okay, and if anything apart from this, ये जो 3 carries है, these carries are not final carries, they are supporting these addition, right? So this will be considered as auxiliary carry. So if auxiliary carry is generated, this bit will change its status from 0 to 1. And if final carry is generated, you will see this bit as 1. Flag registers can be checked. Individual bits, carry bits or auxiliary carry bits can also be checked. Okay, these are all the instructions in your 8086 which can be understood. Clear?
Yes, miss.
Yes, ma'am.
Okay, great. So this is what I was saying about the registers, the instructions. One instruction only we have taken, that is addition, and the flag register, 2 bits of flag registers which we have done. Okay. Now, coming to this part, instruction queue. Okay. When you write down your Java code or C code, do you write down only one thing, system.out.println, addition of 2 numbers is plus C? Can you write down this? Will it return any value? If I don't like public static void main, if I don't declare the variables, if I don't give a function that you have to add, it will give you an error, right? So these steps which are there, they are different instructions, right? Similarly, here we have various instructions. So first is, the first instruction can be moving the data into register 1. Register 1 may I'll put data 1. Register 2 में I'll put data 2. फिर I'll give that I want to add R1 and R2. Correct? So minimum 3 steps are there. So ये जो 3 steps है, they all have their individual instructions. Okay? So यहाँ पे it is an instruction queue. Can I take add R1 R2 first and then give the values of R1 and R2? No. पहले मुझे R1 का value shift करना पड़ेगा. Then I'll have to define the value for R2 and then only I can add it. So it is an instruction queue which will give one instruction to the ALU. Okay, that first, please store first data in AL, then take second data, put it in AH, then add these 2 numbers. So there's instruction. Okay, they follow a line. So that instruction queue is given over here. Okay, so there can be n number of instructions which we'll write. We won't write only 3 lines of code. We may have 20, 25, 30, 35 lines of code. Okay, this is very simple to write. So that queue has to be maintained. Okay, then where does this queue come from? Okay, so the address bus which is there. Okay, these are some sections which we'll see later on. They will, where I want to store this, okay, I want to store it in AH and AL. So when I write down AH and AL, they also have some specific address. So that address will be generated over here, okay, and it will be given to the address bus. As I told you in the start itself, if I don't have the address, my data cannot be passed, okay. So I need to first denote the address. And then I have the data which I'll pass, which will go to the control logic, which will give to the instruction register whether I have to read the data or I have to write the data. So R1 and R2 are writing to the microprocessor, and when the answer comes into an accumulator, that is, we are reading the answer. Okay, and then it will go to the 8086 bus. So we'll see this in individual things as well. Okay, so this is a dedicated adder, okay, to generate the 20-bit address. Now, why do you require an adder to generate the 20-bit address? We already have an address bus of 20 bits, right? But the address generation which is there takes place only with 16 bits. Why 16 bits? Because all my registers over here which are there, they are only of 16 bits. Make sure you have understood the difference between address bus and data bus. Okay. Whenever I want to give the address, okay, whenever I'm defining the address, it is also through one of the registers. Register का capacity कितना है? 16 bits. But address bus को requirement is how much? The requirement of address bus is 20 bits. So there is something which I will do of this address generation adder, which will convert this 16-bit address to a 20-bit address. Okay. Again, we'll see this in detail in the next coming slides. Okay. So now let's see in detail about the segment registers. Now, please take your calculators, come out of the base. Okay, hexadecimal decimal se normal calculator pe aa jao. Take 2 raised to 20. You already know the answer. Okay. And if I want to 2 raised to 20, if I divide it by 4, what answer do I get?
Mom, 262,144.
Okay, can anyone tell me what is 1 KB? What is the value of 1 KB?
1024 bytes, ma'am.
Correct. It is not 1000. We will consider it as 1024. Okay. K, when you take it in registers, it will be resistors, your analog resistors. All those resistors will take the value as 1000. But when you come to the digital side, 1K stands for 1024 of. Okay, so you have to keep this in mind, because every calculation which we'll be doing will be with respect to 1024. Okay, so now these are some of the segment registers. Okay, so you can see CS, DS, SS, ES. Again, everything is written in the short form. So CS stands for code segment, DS stands for data segment, SS stands for stack segment, and ES stands for extra segment. Okay. So now what microprocessor does is, it was not so smarter to understand everything. So whenever you are writing a code, आपको उसको बोलना पड़ेगा that I am writing a code. So please save this in code section. Okay, so we define a code section, and whatever is your code, we will write it down in the code section, and all the instructions will go into code. Next, I told you that the instruction for adding and moving is also converted into hex. Right? I gave an example that move instruction may take it as 3A or 3E or anything, but it is a hexadecimal number. Data is also hexadecimal. So we have to make sure that 8086 does not confuse between what is the address and what is the data. Okay, so for that, we have divided its segments. So code section we will define a code segment and we'll write down the code. If I want to have some data, I will first define the data. Okay. In your Java code or your C code, आप लोग पहले integer define करते हो ना, int, not the data type, but you give the variable first. So first we will define the data by writing dot data. So it will come to know that whatever I'm writing over here is my data. For defining a code segment, I'll write down dot code. And whatever I write down over here will be treated as code and it will be stored in the code segment. Okay. Extra segment and stack segment we'll study later on when we'll start with the coding. Okay. Next is IP. It is very important. Okay. IP stands for instruction pointer. Okay. IP stands for instruction pointer. Any diploma student who has studied 8085?
Yes, miss, we have studied, but miss, right now we are
Okay,
not-
okay, no, I'm not asking anything, but just you have studied 8085, right?
Yes,
Ma'am,
miss.
not 8085. We studied 8051.
8051. Okay, that is
Yeah.
also fine.
Microcontroller.
Okay. So in 8051 or 8085, you might have heard about program counter.
Yes, ma'am.
Okay, that program counter is nothing but instruction pointer in 8086. Okay. So now, what I want to do, what I want you all to understand is, I have to start with some of the coding, okay, to make you all understand. Move AH, comma 26 hex. Move BH, comma 3A hex. Add AH, comma BH. Okay, this way I will write down the instructions. Now I am moving the data from source to destination. Outside is the source, inside is the destination. Okay. And when I write down AH, comma BH, this is just the example. This is not the actual coding. Okay. I'll show you how the actual coding is done. So addition of AH and BH, the answer has to be stored in AH. Okay. So now, when I write down the code, there is some memory address. As I told you that data has to be stored, the code has to be stored. So ये जो मैं code लिख रही हूँ, which will be stored in dot code. So before this, I will write down dot code. So it will come to know that what all things I am writing down is a part of my code and not just the data. So suppose it starts from the address 0000. After that, the instruction will come 000. It will not come 1. Okay. What it takes is it will come 16 bit of data में वो divide करेगा. So just for simplicity, I'll take 0001, 0002. Okay. So very first instruction is what? Move AH, comma 26 hex. So right now, before I execute my program, okay, anything, before I start running my program, my IP will be at its default location, that is 0000. After I execute, okay, the first step, 0000, whatever the instruction is written, it will execute that. After that, it will increment to 0001. So basically, IP tells you which instruction needs to be executed next. Okay. Now this is generally when we write down the coding, it will always be in the ascending order only. It will increment by 1, 1, 1, 1, 1, 1, 1, depending upon what instruction you are writing. Unless and until you give some jump instructions. Okay, jump is nothing but the looping instructions of your C and Java. If I write down for, okay, for is a continuous loop. Okay, till the time the condition is not satisfied, it will stay in that loop. So I have reached to this point. Okay, it is executing some point over here. It is reaching this point, but this condition is not satisfied. It is telling that I have to go to this particular instruction. So I'll say that if suppose this is instruction location 10th and you have to jump to location 4th, this is going in reverse order. So depending upon the coding which we write down, instruction pointer will point towards that instruction. Okay, and it will let you know which instruction is to be executed next. Correct? So simple definition, what is instruction pointer? It will point to the instruction which needs to be executed next. Now, where is this instruction stored? In the memory location. So to enhance the definition, we will say it points to the address of the instruction which needs to be executed next. Am I clear? Clear with this definition?
Yes, please.
Okay, it points towards the address of the instruction which needs to be executed or which is going to be executed next. Correct? So this is the part of, this is the role of instruction pointer. Okay, understood what is code segment and data segment? Okay, हम कोड कहाँ लिखेंगे? Code segment पे. We need to tell the microprocessor that this is not the data, this is my code. So whatever I'm writing, please store it in your code segment. When I write on dot data, I'm writing, I'm telling that please store this in your data segment, not in your code segment or extra or stack segment. I have to define all these segments before putting in the data. Correct? So now all these segments which are there, okay. So the segments which are there, they will be, it is possible that I am using the segments continuously. Okay, the data is going continuously. It may be slightly overlapped, okay, partial overlapping. It may be completely overlapped, or it may be disjoint. Okay, abhi there is a limitation. 8086 has only 1 MB of memory, so there is a chance that the segments are overlapped. Okay, so how to see that? How is it given? So 8086 1 MB memory is divided into segments of up to 64 KB each. So now, can you divide 1 MB by 64 KB and tell me how many segments are possible?
Ma'am, 16 segments.
Okay, so how did you do it? 1 MB divided by 64? Okay,
KB.
which will give you how many? 16 segments, right? So there are, it is told that 8086 1 MB memory is divided into various segments of up to 64 kilobytes each. So maximum capacity of one segment is only 64 KB. Okay. Next, the 8086 can directly address 4 segments, okay, 256 KB within the 1 MB of memory at a particular time. Okay, so out of 64 KB, I say that there are 16 KB which are divided, and out of 64 KB, 16 segments, I can access 4 segments at a time. Okay, so it is 64 KB into 4 will give me 256 KB. Okay, so at a time I can use only 4 segments, which will be of 64 KB maximum, which will exhaust the 256 KB of maximum limit at a time what it can access. Clear about this calculations? First, we will repeat. Yeah.
Sorry, ma'am, can you repeat?
Yes, sure. First, everyone please use the calculators. It will be much easier for me to explain. Take 1 MB, divided it by 64 KB. You are getting how much? 15.625. So I can say that it is, this 1 M is taken as 1000. Okay, so if I do 2 raised to 20, okay, into, divided by 16 into 1024, 64 into 1024. So we'll get exact answer, that is 16. Okay, what I have to do? 2 raised to 20 karo. Okay, it will give you the answer 1 MB. Okay, usko what you have to do? Divided by 64 KB karna hai. So we'll do 64 into 1024. K is not 1000, K is 1024. So 2 raised to 20 divided by 64 into 1024. What answer you are getting? It will give you exactly 16. Okay, getting it, everyone?
Yes, ma'am.
Yeah. So you're getting 16 segments. Okay, so here it is written that it is divided into segments of 64 kb each. So it comes 16 segments, but it is also told that I can access only 4 segments at a time. So एक segment का maximum memory कितना है? What is the maximum memory of one segment?
64
64 kb. So now, can you tell me the decimal equivalent of 64 kb? 64,000 mat bolna. If I'm considering it 64 into 1024, it will give me 65536. Okay, this is a very important number, 65536. Everyone please remember 64 kb is 65536. This is also very important for us in microprocessors. Okay, so 4 segments. So 65535 into 4. Okay, 64 kb into 4 will give me 256 kilobytes. Okay, so I'll get 256 kilobytes within one memory, 1 MB of memory at a particular time. Correct? Any doubts here? Next, the program obtain access to code and data in the segments by changing the segment register content to point to the desired segment. So now I told that total 1 MB हमारे पास में है, but out of which I can use only 256 KB. Okay, for the segments. So I can, if I don't have data, okay, if I don't have data at all, I can increase my code segments memory. Okay, if I have more of data, I can use segment, the stack segment as well as extra segment. So every program has an access to code and data memory, okay, by changing the segment register contents. What is the segment register contents? That we'll see later in the next lecture. This is clear? Anyone has any doubt in today's lecture? We'll have to stop here.
Ma'am, can you explain the diagram on the
Which
top
diagram?
once again?
Yeah.
This one?
So I told you that the address of 8086 is 16 bits. Okay. So here the addresses are mentioned. Okay. So total we have 1 MB of memory. Okay. This year it will be 1 MB. So the last line it is written that every program which is there, it can access the code memory and the data memory. Okay. Memory, or as in I can say as a segment. Okay, so data segment and code segment is compulsorily or easily accessed by any of the code. For stack segment and extra segment, we need to define separately. So for every segment which is there, there is a register which will point to that particular segment. Okay, this we'll see in the next lecture. So what happens here is the segments which are there. How many segments are there total? 16 segments we calculated, right, in 1 MB of memory. So these 16 segments which are there, it can be code segment, it can be data segment, it can be stack segment, it can be extra segment. For different codes, the value of these segments or the memory of these segments can be maximum 64 or it can be less than 64. So if it is less than 64, can I use that particular segment for another use also? Maximum is 64, but suppose if I am taking just 16 KB, the remaining part is free, correct?
Yes,
Out
ma'am.
of 64 KB, I am using only 16 KB. So remaining the remaining space is empty. So I can use that particular segment for other things also. So the segments which we have, it is possible that it may be continuous. That means this is start from 0, it is ending at 1, this is starting at 1, this is ending at 2. Okay, let's take this example as 0, 1, 2. So this part which is there, it is also possible that for some other application, it is taking it from 1.75 and it is ending it at 2.5. Okay. The same segment is also taking up the same memory of 1.75 to 2.5. Okay. So if you see the continuation, this is first segment, this is second segment, this is third segment, this is fourth segment, and this is fifth segment. So each segment which is there, it will take up some memory in from the 1 MB of memory. Okay. So code segment अगर है, एक program का code segment is taking this value. So same memory, okay, can be taken as a data memory for other program. Okay, it is a segment. This segment is different, and this segment is different. But it is not fixed that code segment will have to be only from 0 to 16 bytes. इसको 17 kilobytes से 20 kilobytes तक. It is not defined. Okay, it can point anywhere in 1 MB memory. Okay, so suppose 0000 पे I have defined a code segment for one program, and 20,000 पे I have defined data segment. Okay, it is possible that for another program I will define this as code segment and this as data segment. Okay, so every data which is there in your memory can be overlapped. So this is what is shown, that the segments can be in continuous unless and until you define it, but obviously we won't know. So it can handle the partial overlapping, it can handle the fully overlapping, or it can handle an individual segment which can be anywhere in the memory. Got it?
Oh, yes, ma'am.
Okay.
Ma'am, so the segments are predefined, or we have to define it every time?
We will define it. There are segment registers. Here it is mentioned. There are segment registers which we will define. Okay. So when we write down dot code in the code, it will take some random address in the memory. Okay. When I write down dot data, it will take any random memory. It may be same, it may not be same. We are using the softwares. So for some of the versions, this dot code address will remain same, the dot data address will remain same. If there is a version change, okay, there may be possibility that the dot code is taken in some other memory. Okay, but maximum value will stay as 1 MB. Okay?
Yes, ma'am.
Anything less than 1 MB, it will take as a segment. When we'll do it practically, I'll show which is the code segment and what is the address of that code segment. Okay?
Yes, ma'am. Yes, ma'am.
Okay, so thank you everyone and for making